Electrical resistance is defined to be the ratio of electric potential difference to current. When the electric potential difference is measured in volts and the current is measured in amps, the resistance will be given in ohms. 1 ohm of resistance basically means it takes 1 volt of potential difference to produce 1 amp of current through that electrical device. All electrical devices have resistance, and you can find their resistance by connecting a voltmeter across that circuit element and an ammeter in line with it to measure your voltage and your current. Divide those to get the resistance. Some circuit elements simply serve as resistors in order to regulate the amount of current through that part of the circuit. Other resistors produce light or heat or motion. Whenever the resistance of a resistor remains constant, that is, the ratio of potential difference to current stays the same regardless of how much potential difference or current goes through the resistor, we say that that resistor obeys Ohm's law. Ohm's law basically states that the resistance remains constant. Circuit elements that get hot generally do not obey Ohm's law. The resistance increases when the voltage goes up or the current increases. In a common lab activity to measure resistance, we connect a resistor to a power supply, run current through an ammeter, and then we put a voltmeter across the resistor to measure the potential difference. As we change the voltage by adding in more cells, we get different voltage and current readings. If you divide the voltage reading by the current reading, you get the resistance in ohms. In this activity, I will connect the circuit with a resistor. They're color-coded. We're going to use a brown-black-brown, a brown-green-brown, and a red-red-brown resistor. We're going to use those, collect our data, and you will calculate the resistance and graph your results. Okay, I'm going to use the 2 multimeters to measure voltage and current across and through the resistor. For the multimeter set to voltage, I'll click it to volts in DC, direct current, and it will read the voltage in volts. For the ammeter, I mark it to milliamps. Because this will be given in milliamps, you'll need to move the decimal 3 places to the left in order to get your current in amps. We're going to go from our power supply to our ammeter, and so I'm going to connect the ammeter right there on the end of our power supply, and then from the ammeter we're going to go to the resistor. Now this first resistor is a brown, green, brown resistor. It's brown, green, brown. Then we're going to go from the resistor back to our power supply. And so when I connect this clip to the power supply and we have a complete circuit, we get a current reading. Now in order to get the voltage across the resistor, I need to connect my voltmeter in parallel across the resistor. Now because this is the positive end of my cell, that means that this will be the positive end of my resistor, and I'll connect the negative, the black lead, to the opposite side, the negative side. That'll give me voltage readings that are positive. Now at the present time, when we do not have current flowing, we have no volts, no amps, 0, 0. But now I'm going to connect to one single dry cell, and we get a reading of 1.551 volts and 10.33 milliamps. When we move over to power it with 2 cells, the voltage rises to 3.08 with 20.5 milliamps of current. We'll go to 3 cells, and you can see the voltage and the current reading. We'll go to 4, increases our voltage and our current. We'll go to 5, voltage, current, and then we'll go to 6 cells, voltage and current. Now that we've finished the brown-green-brown resistor, I'm going to disconnect, and we're going to connect brown-black-brown. So our second resistor is brown-black-brown. So all I have to do is replace the connections with the brown-black-brown resistor in line. You'll record current and voltage readings like we did before. So there's one dry cell powering it. We go to 2. 3. 4. 5. And 6 dry cells. All right, our final resistor that we're going to measure is going to be red, red, brown. Red, red, brown. So I remove the brown, black, brown resistor. I connect the red, red, brown in its place, and we go through the same process again. I believe there might have been something wrong with that first reading there. That looks a lot better. So there's with 1 cell, 2 cells, 3, 4 cells, 5 cells, and 6. So for each trial, you will divide voltage by amps in order to get the resistance of that trial. You'll average your trials together for each color-coded resistor to get an average resistance. You will also make 3 graphs, one for each resistor, where you graph potential difference as your Y versus current as your X. The slope of that line will also give you the resistance value of that color-coded resistor.